Very good. So no matter what you do, this is what you get. So in the second generation, when you make this with itself, what I said would now happen, right? Do you get that?
So TS and RW are the first one.
Because now you will have a TSRW, which is basically all the letters are there, and then you have another TSRW. And what happens? You could get either from here, you could get either from here, you could get either from here, you could get either from here.
So now we could get a TT, right?
You could get a TT, so all the 9 combinations that we listed would happen. Because the problem then becomes of how many ways you can choose all these letters coming independently from each side, right? And there are 9 combinations possible. Are they all going to be equally likely? So for example, is the TT RR compared to the TS RW, are they going to be equally likely to happen?
No.
Which one is going to be more likely?
TTR.
This one? Think again.
TSRW, yeah.
TSRW. Why?
Because TSRW, you're taking genes from both sides. So because TT and RR,
Mm-hmm.
those genes are
Why do you think they will not be equally likely? How many ways can you get TT? You get this guy and this guy.
Oh yeah,
That's the only way you can get TT, right?
Yeah.
How many ways can you get TS?
TS you can get 2 ways.
This way and this way, right?
Right.
And how many ways can you get SS? Again, only one way,
Yeah.
right?
Uh-huh.
And what about the R's now?
The R's can only happen once. RR.
Right. RR, then what about the rest?
RW.
You can have RW.
RW can happen, let's see.
So this can happen once, and this can happen once. This can happen how many times? Two times, right? And this can happen how many times?
So that means
Once.
once.
Right? How many ways can this happen? Once. How many ways can this happen?
Twice.
Two, right? Same thing. You can take this with this or this with this. And then this can happen once. Right? So then what's the chance that you get this TTRR? So now you can tabulate what are the different combinations possible, which I'm going to do. So you have TTRR once, and let's write the once. Now what are the other combinations? So you have a TS, and you can have a R with it. TS can go with a RW with it, and TS can go with a WW with it, right? And TS happens twice, this happens once, right? So this happens 2 times, right? TS happens twice, RW happens how many times?
No, twice.
Twice.
4.
So this is 2 into 2, right?
4.
4. TS happens twice, WW happens once.
2.
How much? 2. Okay, let's complete this table. So what would be the next? So TTSS we covered. At least. And then what's left now? Actually, I should have completed. I'm not going in the right order, but okay. Let's do now TT with, we only covered RR, right? So what is remaining? RW and TT with WW. So how many do we have here? Good. This is 2, and this I think TTWW. This is 1, and then what else do we have? So I'm running out of space, so let me create some space. So what else is remaining? So now we have to have SS with, what is the thing we missed? SS with RR and SS with RW. And how many are here?
Once.
1.
2.
SSRW?
Twice.
Good. And then, what is missing? So we did all the combinations for SS. We did all the combinations for TT. 3 combinations for TT. 3 combinations for TS. And 3 combinations for SS, right? Yeah. So I think we are done. If you add it up, how many will be there?
16, so that means all of them were
16? You counted it?
1 plus 2, 3, 5, 9, 15, 16,
16, right? So the combination of 16 was absolutely right. But you have 9 unique combinations, right? And now you can say what is the chance that you get this particular thing, this particular thing, this particular thing. They are all sort of unique, right? In terms of combinations, in terms of letters. But they have different probabilities. So this is Mendel's second law. It says that these 2 characteristics, they change independently with respect to each other. They segregate independently with respect to each other. If this was not independent, what would have happened?
there would have been.
Tell me from here what would have happened. Suppose this was not independent.
If they weren't independent,
Yeah.
then there would be fewer combinations.
Okay.
And
Anushree?
then T could have gone with the R instead of only going TS. It could have been TR or TW
Absolutely
or
right.
SR or
Absolutely
SW.
right. So you couldn't have had all these combinations, right? If you said that T only goes with capital T only goes with capital R, well, this wouldn't have worked. This wouldn't have worked. The reason all these work is because they are independent. And this is very, very important to understand when you are understanding all the problems that will come in science Olympiad. Because as we go forward, you'll see that why Mendel's laws are the way they are and under what circumstances they don't hold good. So now we are still not done with Mendel. There is yet a third thing that Mendel said. And what do you think is that third thing? And in the process of actually going through his experiments, I've told you about that third thing. Okay, can anybody guess what that third thing is? Okay, so what's the difference? So if I have a plant and internally it is a TT, and I have another plant and internally it's a TS, and you understand that two are different, right? They'll breed differently. Can you tell me if they are different? Just by looking at the two plants? Why not? Go back to what I said. When you took a tall plant and mated it with a short plant, some of them are not purebred, right? That you got, right? But they are not purebred, yet they show up as tall plants. So their shortness is somehow hidden. It's not showing up. Does this make sense? Does it make sense? So what he said is, among the characteristics, some characteristics dominate over other characteristics. So in other words, if you have, everybody will have two copies of some characteristic. If you are purebred, doesn't matter. The two copies are exactly the same. But if you are not purebred, even though you have some shortness hidden in you which will show up when you mate, when I look at you, I won't know, right? And what he said is, this is a dominant trait. So if you have one part of you telling that I'm tall and the other part telling I'm short, the tallness will dominate over shortness. And he called this a dominant trait, and he called this the recessive trait. So it's not blending. If you have two of them, only one shows up. And then as people later understood the molecular basis of like why this happens, they started calling this the genotype and the phenotype. So the genotype is what you have inside you. It's like both the tallness and the shortness. So if somebody asks me what is the genotype of a purebred, it's TT. What's the genotype of a round P, of a pure round P? RR. What's the genotype of a tall mated with a short, which still looks like tall? What is its genotype? TS.
But the
What is its phenotype? Tall. Phenotype is what actually shows up. Genotype is what is there inside you. This is very, very important. There will be a lot of questions which need you to understand what genotype is and what phenotype is. So make sure you understand this. Genotype is what is inside you. Phenotype is what shows up. And if you have a mix of a dominant trait and a recessive trait, only the dominant will show up. So in this case, let's look at each of these combinations, are they different genotypes?
Huh? Wait,
Each of these combinations, are they different genotypes? Yes. Who
yes.
said yes, who said no?
All the genotypes are they?
Does anybody say no? Does anybody say yes? Does anybody say, I don't understand? I don't get it. You don't get it, right? Okay. Okay. So if you look at this combination, this one is a pure short and a pure round, right? You get that, right? Look at this one. This is a pure short, but not a pure round. It's a mix of round and wrinkled. Between these two, if you look at these two plants, can you tell if they are different? Can you? You can't, right? That's exactly what I'm saying. You can't, because the roundness
Takes
here
over.
will dominate over the wrinkledness. So if you have both of them, the fact that you have the wrinkled is not going to show up. So, and because each of these letters, somehow they differ in a place. They are all different genotypes. So, what does genotype then mean? If you took any of these plants, right, and mated them with each other, just like you did, go one more generation, they will not give you the same results. So, these are 9 different genotypes we got by doing this mating with 2 characteristics. Now let's look at how they look. Okay, this guy looks like a how does this guy look? Short and round. Short and round.
Just round.
How does this guy look?
Short and round.
Short and round. Are you surprised?
No. No.
And this is the phenotype. Phenotype is how you look. So even though you may have 2 different genotypes, the phenotype could still be exactly the same. You can't tell. And how would you tell that they are 2 different genotypes? I give you 2 plants.
You made them to the next generation.
And then you get a wrinkle.
That's one way. You'll see different results if you made them. Is this clear? Clear, Brandon? So, and finally, I will talk about something else. So we talked about genotype, we talked about phenotype, and then this thing, each of this trait is called an allele. So for example, this S is an allele. This roundness is an allele. Now, this particular pair is called a gene.
Are the alleles only dominant or can they be recessive?
Alleles can be, you tell me,
They can be
it can be either, right? You can either get a T or you can get a S. They are two different varieties. So Mendel called them like two different, I don't remember the term, traits or of the same attribute. These are two different traits, two different distinct flavors, right? And later on, as people formalized this, they came up with these names. Okay? Does it make sense? You need to know these four terms very well. A gene, this pair of two things that every individual has is called a gene. The particular one that comes as part of the mating process, that's an allele. So in this case, there are two alleles here. There is a allele for tall and there is an allele for short. So, and then you have genotype and phenotype. Genotype is what you have inside you, which will only show up when you mate up, and phenotype is what you show as. And remember this, the number of phenotypes are always going to be less than the number of genotypes. Why?